But most of these form those circular, upraised areas. And even though we have so much typhoons in Guam, these just seem to be very hardy. They're rooted so deep that they're very rarely uprooted. In fact, I've never seen it uprooted. It's very hardy. Although a house can blow apart, these are extremely hardy. Now, if we look at the seagrasses from Palau, Yap, Chuk, Pohnpei, Kosrae to the Marshalls, going from west to east, we can see 10 species in Palau. In the Yap, we have 7, Chuk 5, Pohnpei and Kosrae 3, and the Marshalls only 1. So in March, in January of this year, I was in Kosrae and trying to look for a 4th species. But so far, we only have these 3 species. Now, also you can find algae within this area. And I just want to go very quickly over this, this portion. Enteromorpha clothrata. We don't have that much ulva in the Micronesian area. But Enteromorpha is the one that just takes over the intertidal area. And the reason why I'm showing this is we have the Enteromorpha here, and we can find seagrass in this area here, just off the intertidal area. Ulva lactuca is very, as I said, very rare in Micronesia. We've only found it in Palau, on the island of Peleliu, in Yap on the west side, in the harbor area, and there is a record from the Kiribati, right below the Marshall Islands, on Tarawa area. We do have records from Guam, however, they're found 200 meters deep. They're all deep water. The Tonson Cromwell went there, did some dredging, and it seemed that every time they put the dredge down and came up, they always came up with this ulva. And only once, I think, we found one sprig of ulva on shore. It may be that the fishes ate them when they came up or couldn't germinate, but we just don't find it on the islands. Another one that you can find in the seagrasses or on the side of the seagrass is Halimeda macroloba. It's not a clear picture, but we can see all of these Halimeda. And these Halimeda life cycle is about only 4 or 5 months. After the first shoot grows, after 4 months, in unison, they all fruit. In other words, these all consist of siphons, and all their siphons stream toward the tops, form these little grape-like structures, the gametangium, reproductive bodies, and then they release the gametes, which fuse, and within 3 days, all of this dies off. That's why you find the Halimeda in the sand so plentiful. So within this 4 or 5 month cycle, these grow, fruit. Within 3 days, they're just totally white, dead, fall apart. Next generation comes on. It's just a continuous process. Another Halimeda that you always find among the seagrass, Opuntia, Caulerpa, Taxifolia, Sertularioides, and some forms of Caulerpa racemosa. This one is found on dead coral limestone, but you can find this also within seagrass beds. We do find at times blue-green algae, cyanobacteria, Lyngbia, Schizothrix. Then we also find some reds. This is a dried up Gracilaria salicornia. That's a better one. This shot was from Hawaii. And we find this among the seagrass. Another one, Gracilaria, that's okay. This particular Gracilaria, in April of 1991, people collected it on Guam in a certain area, and 3 of them died the next day. 6 others were hospitalized, 7 others were treated privately. And since 1991, they've closed the area. No one really knows what's causing this. Is it the seaweed itself, or is it some invertebrate on it? To this day, no one really knows. In 2001, I did send more samples to Japan, where they were doing the testing. The mouse that they tested this on did die. No, I take it back. Earlier ones died. This one, the mouse was sick, but it did recover. So it was mildly toxic. Now the interesting part is we're finding this throughout Micronesia. We're finding in Yap, and only in the seagrass beds. We found it recently in HCRI, in the seagrass beds. Now, I don't know if these are toxic, but this is the only Gracilaria or Ogo that is the more like the edible type. Previous to these people dying, I would pick it up in the field and just chew on it. In fact, can you imagine we had 2 years of sea grant funding from University of Hawaii to work on this aquaculture. We even sold it at the marketplace, and nothing happened. But this is still under study. Here's another, used to be called a Gracilaria, Hydropuntia now, only found in seagrass beds. Capophycus alvarezii, that's named after Vic Alvarez, who did mariculture work with this is the Yukiyuma, the infamous Yukiyuma in Kaneohe Bay. They brought this to Micronesia. They were growing this in seagrass beds. In the seagrass beds with Thalassia, not with Anhalis. Anhalis grew too tall, would tangle in the ropes. So you stay away from Anhalis. But in most cases, you stayed away from the river areas. So, but you do grow this, you can grow this in the seagrass area. In the case of Palau and Pohnpei, the mariculture business went kaput, mainly because of the rabbitfish. Apparently the rabbitfish preferred eating this particular alga in the seagrass. So he kind of closed that aquaculture business. You don't have rabbitfish here. We have lots in Micronesia. It is the favorite fish. In fact, when you're in a boat, say in Yap, I can get a couple rabbitfish for 2 sticks of cigarettes just in the field. Now, if we look at the zonation of these, as I mentioned earlier, Thalassia cymodosa inhalis, you find it in the intertidal shore. You can find Thalassia cymodosa also in the subtidal. It's not exposed. You also find these other 3, Syringodium, the 2 species of Halophila, and Halodule. Then deeper areas, you find the same Thalassia and cymodosa that can occur in deeper water.